summarize the results. So the summary of stresses on inclined planes is sigma x dash. So sigma x dash is stress along the x dash plane. How do we find that? That is going to be sigma x plus sigma y divided by 2. This is the first term. Next term is plus sigma x minus sigma y divided by 2. Now the next term is we have cosine and sine. In case of sigma x dash, it is going to follow the alphabetic order. That is, cos 2 theta is going to come first. Then we have tau xy into sine 2 theta. Now, once you know sigma x dash, sigma y dash can be found out from this relation, that is sigma x dash plus sigma y dash is equal to sigma x plus sigma y. So this is the first formula and this is the second formula. Third formula is for tau x dash y dash. How do we find this? We only require this much portion of the equation. So we will have a negative sign to begin with, and the first term will be sigma x minus sigma y divided by 2. We had cos 2 theta here, so it is going to be sine 2 theta here. Next one is again plus tau xy. We had sine 2 theta here, so we will have cos 2 theta here. So this is the final summary expression which you have to remember. Now with this idea, what we are going to do is, let us try to solve a numerical example. So the question we have to solve is, the state of stress inside a point is given as this is 80 megapascal, this is 50 megapascal, and we have shear stress 25 megapascal. Now this is a state of stress at a particular point inside a material. Now what is the question that is asked is, we need to find the stresses at that point. So it is the stress at the same point for an element that is oriented at 30° clockwise of x-axis. So 30° clockwise of x-axis. For that particular element, we need to find the stresses at the point. So again, stress at the point is dependent on the orientation of the element that we are considering. So we are given one state of stress for a particular orientation of the element. We have to find the state of stress at that point for a different orientation of the element, and that orientation is given. Now first thing we have to do is, we have to take down the features. So if you look, the standard element that we had considered is this. This is the standard element that we have considered. Okay, so these are the positive directions that we have considered. Also, if you remember, the thetas that we considered is, this was one of the theta, or the other theta was, the normal is making an angle like this. So either the inclined plane is making an angle with the vertical, the inclined plane either makes an angle with the vertical, that is theta is the angle made by the inclined plane with the vertical, or theta is the angle made by the normal to the inclined plane with the x-axis, and that is measured in the counterclockwise direction. So this is very important. So what is theta? Theta is angle of the plane with vertical, so that is one thing, or theta can be angle of normal to plane with x-axis in anti-clockwise direction. So these are the things. So let us compare. If you look here, sigma x is negative because it is in a different direction. So sigma x is minus 80 MPa. Sigma y, if you look, it is tensile, so you can take it as plus 50 MPa. And shear stress, as you can see, it is acting in the opposite direction, so it is minus 25 MPa. And lastly, theta, as you know, theta has to be positive, then it has to be anti-clockwise. However, here theta is clockwise, and therefore we take it as minus 30 degree. So these are the four values that we are having. Now all we have to do is directly substitute into the equation. So let us try to do that substitution. So sigma x dash is equal to, as we know the equation, sigma x plus sigma y divided by 2 plus, next term is sigma x minus sigma y divided by 2. Alphabetic order is followed, therefore cos 2 theta comes first, then tau xy into sine 2 theta. So if we substitute the values, it is going to be minus 80 plus 50 divided by 2 plus minus 80 minus 50 divided by 2 into cos 2 theta. So cos 2 theta is going to be cos minus 60 degree plus tau xy is minus 25 into sine 2 theta is going to be sine minus 60 degree. So if we try to solve this, what we are going to get is minus 25.85 megapascal. So this is our first answer. That is the answer for sigma x dash. Now next thing is we need to get sigma y dash. So to get sigma y dash, sigma x dash plus sigma y dash is equal to sigma x plus sigma y. So if we apply this, we are going to get sigma y dash is equal to minus 80 plus 50 plus 25.85. So if we do this, we are going to get it as minus 4.15 megapascal. So that will be the value of sigma y dash. So sigma y dash will be minus 4.15 megapascal. So we have sigma x dash now, sigma y dash is also available, and the last thing is we need to find out tau xy. So again the formula for tau x dash y dash is, first thing is we have sigma x minus sigma y divided by 2. We need to put a negative sign in front of it. Next thing is sigma followed alphabetic order. Here it is the reverse. So sine 2 theta comes first plus tau xy into cos 2 theta. So if you substitute, minus sigma x is minus 80 minus 50 divided by 2 into sine 2 into 30, 2 into minus 30, so it is going to be minus 60 degree plus tau xy is minus 25 into cos minus 60 degree. So if we try to simplify this, we are going to get it as minus 68.79 megapascal. So this will be the value of the shear stress. So now what we can do is we can represent this state of stress in as a figure. So what we can do is, this will be the xy axis and the normal to the plane. This is the normal to the plane, and it is making an angle 30 degree, so it is in the clockwise direction from the x-axis. So this is our x dash. So if this is x dash, this will be our y dash. So if x dash and y dash is known, then it is easier to draw the remaining. So all we have to do is we have to draw an element here. So this is the element. Now if the element is drawn known, what we have to do is we have to mark the stresses. So sigma x dash, we got it as minus 25.85. So that means it is acting in compression and the magnitude is 25.85 megapascal. This was also negative, so the value was 4.15 megapascal. It was also compressive. And lastly, for the shear stress, we got the value again as negative. So shear stress would be like this. And the magnitude is 68.79 megapascal. So this is how we represent the state of stress at a point inside the material, and it changes with the orientation of the element that we are considering. Next thing is you can do this as a homework. Try this for yourself. The question is, so this is 14.2 megapascal and this is 8.2 megapascal. This is the representation of the shear stresses. Shear stress is 3.1 megapascal. So this is a representation of the element, and what we require is we require the stresses on an inclined plane. So we require stresses on this inclined plane, and the inclined plane is making an angle 65 degree with the horizontal. Okay, so this is the question. So we need to find the stresses on the inclined plane. So when I say stresses on the inclined plane, the stresses on this inclined plane will be, one is there is going to be a normal stress and another one is there is going to be a shear stress. So these two stresses has to be found out. So the answer for the answer is sigma x dash will come out as minus 10.75 megapascal and tau x dash y dash is going to come out as 4.28 megapascal. So these are the answers. Now one thing we have to remember is in this particular case theta is not directly given, okay, because theta is, we recorded theta as two things. One thing is either theta is the angle made by the inclined plane with the vertical. So in this case if this is 65, this is 90, so this value will be 90 minus 65, so theta will be 90 minus 65, which is 25 degree. Or theta can be the angle the normal to the inclined plane makes with the x-axis in the counterclockwise direction. So either of these can be taken as theta. So the only note you have to, so this is something that you have to note to do this problem. Rest of the things remains the same. So try to do this. We will see with another topic in the next class. Thank you.